We've been playing a lot with tangent lines lately, and I endeavor to give you some problems that aren't just the typical ones. So here is another flavor of a tangent line problem, and it says this: find all. We want to find all the tangent lines to the graph y is equal to x squared plus 4 that end up going through the origin. So I have that graphed over here, and why don't you pause the video and give this a try? Again, we want to find all the tangent lines to this graph that go through the origin. Okay, assuming that you've given it a go, let's just try to visualize what the answer will look like if we get some tangent lines that are tangent to this graph and go through the origin. How many tangent lines do you think there will be? So let's see. To me, I would see one over here. I see one over here potentially. Going through the origin like that. And then I see another one on this other side. I can see another tangent line possibly over here. So my guess would say, all right, we're probably looking at two tangent lines that are going to be tangent to this graph and going through the origin, but we need to prove to see if this assumption, this guess, is true. So let's do that. And how we're going to do that is we need to construct, again, another general tangent line like we did in the last video. A general tangent line for any point along this curve that you give me a point on this curve, and I will give you a tangent line for it. So we need to do that. Let's construct a general tangent line. So a general tangent line. General tangent line. And again, we did this in the last video. So we will construct a general tangent line at the point, just this arbitrary point, x naught, y naught. So what is our general tangent line? Well, in the last video, we saw this as well. We said that we can write down y minus y naught is equal to the derivative at x naught times x minus x naught. Okay, so we saw that in the last video. And again, real quick, I'll just write some notation here. We are saying that y is equal to f of x. And then with y naught, we are saying that y naught is equal to f of x naught. Okay, just some general notation to write down. So let's keep going with this. And in the last video, remember, we needed to find what the derivative is, and we need to do that in this video as well. So let's find what the derivative at x naught is. Let's find the derivative. So we have f prime of x naught is going to be equal to, the definition of the derivative is the limit as x goes to x naught. And we are going to be, this is going to be f of x minus f of x naught. And this is going to be all over x minus x naught. Okay, again, just the definition of the derivative. And now we can fill in. We said that f of x was this graph over here, x squared plus 4. So let's fill that in. So we have the limit as x goes to x naught of f of x, which is x squared plus 4 minus f of x naught, which is going to be x naught squared plus 4. And this is all over x minus x naught. Okay, so now let's simplify this and evaluate the limit. We can see that our 4, when we distribute this negative, the 4's are going to cancel, and then we're left with a difference of squares in the numerator. So we can write that out. We have x minus x naught times x plus x naught. And in the denominator, we still have x minus x naught. And we're still taking the limit. So these will cancel, and we're taking the limit as x goes to x naught. And evaluating this limit as x goes to x naught, we are going to find this is 2 times x naught. So that's our derivative. That is our derivative at x naught. And we can fill that into our general tangent line and keep chugging away. So we have y minus, and I'm going to fill in f of x naught. So that's going to be y minus the quantity x naught squared plus 4. And this is equal to the derivative at x naught. And we found that to be 2 times x naught. So this is 2 times x naught. And we're multiplying that by x minus x naught. So we have all of our pieces here, and now we just need to simplify and solve this for y. So We can add this over and we can distribute this derivative to these terms here. And we have that y is equal to 2, I'm just going to leave it all in yellow now, 2 times x naught times x and minus 2x naught squared. And then when this guy gets added over, we're adding x naught squared plus 4. And then we can just do one more little bit of simplification. So we have y is equal to 2x naught times x minus x naught squared plus 4. And that is our general tangent line right here. Again, it's saying you give me any point, give me an x naught value, and I'll be able to give you a tangent line for this curve at that x naught value. And that is what we need in order to talk about, okay, how do we now constrain a tangent line to go through the origin? Well, we take this general tangent line equation that we just found, that we just spent all this time making, and we need to constrain it to go through the origin. So we're going to find basically the intersection of this tangent line here going through x is equal to 0 and y is equal to 0. So let's write down what we just said. We have this general tangent line, 2 times x naught times x minus x naught squared plus 4. And we want it to go through the origin. So that's when x is equal to 0 and y is equal to 0. And just real quick, you could see that, if this problem was asking, okay, go through a different point, well, this is where you would change that. You would change this x and y value to represent that other point you want all these tangent lines to go through. So now all we need to do is plug in x is equal to 0 and y is equal to 0 into this general tangent line, and we'll be able to get an x naught value. So let's do that. Let's plug in that point here. Let's plug in the origin. So we get 0 is equal to 2 times x naught times 0 minus x naught squared plus 4. This will go to 0. We can add this x naught squared over. So we have x naught squared is equal to 4. And then we can take the square root and we will get x naught to be equal to 2. And we will also get x naught being equal to negative 2. So you can see here we have two values, and now to get our general tangent, to get our tangent lines for these values, all we need to do is plug that back into our tangent line equation. And again, we have two values here, so like we guessed in the beginning, we are going to have two tangent lines that fit this condition. So let's find out what they exactly are. So this will be for x naught is equal to negative 2, and we'll just plug that into our general tangent line. So we find that y is equal to 2 times negative 2 times x minus negative 2 squared plus 4. And we see that this is going to be negative 4 plus 4, which is 0. So we find y to be equal to negative 4x. Now notice, if we were to plot this, we'll plot this maybe in a little bit. If we were to plot this, well then you can notice we can look at symmetry here. We're going through the origin and our parabola is symmetric about the y-axis. So we should guess that our other tangent line is going to be y is equal to 4x. So let's see if that's the case. Maybe I can erase some of this. All right, grab some more space. There we go. So this is going to be for our other x naught value, which is 2, and then plugging this in, let's see if we get y is equal to 4x. So we have 2 times x minus 4 plus 4. So we find that it is y is equal to 4x like we thought. So now we have these two tangent lines, and let's wrap this up by graphing these. So I will graph y is equal to 4x first. 1, 2, 3, 4 over 1. And let's see if I can get a tangent line to fit this. Here we go. Tangent line goes through that point, through the origin. It's not perfect, but there we go. There's one. And then we can get this other one here. So 1, 2, 3, 4, negative 1. Let's see if we can get one to go. That one is not perfect. Let's try once more. Here we go. Let's try once more. Right there. All right. That'll do. And we will make this one pink to make it extra special. There we go. All right, so that's our problem here. And again, we had to just make a general tangent line, and we said we're going to put specific parameters on it. We want it to specifically go through the origin, and we found two tangent lines that fit that specification.